Now, let's understand one of the properties of a sorting algorithm is called as an in-place sorting. So this is the property of a sorting algorithm. By the way, this is not a new sorting algorithm. It is just a property. Now let me explain what this property means and why this is important. And insertion sort as this property, in other words, I would say insertion sort is in-place sorting algorithm. So insertion sort is a in-place sorting algorithm. Now let's understand what does this in-place mean. So in simple terms, in-place algorithms sorts an array without using any significant extra amount of memory. It doesn't create another array to store the sorted result. So instead it rearranges the elements within the input array. So this is what the in place means. Now let's understand these three statements through an example so that we'll get a better idea what does in place mean. Right? Now let us look at our example. So again, I'm just going back with the pseudocode what I have explained in the last video. So this is the pseudocode I have. So for the function called an insertion sort, what is my input here? The input is array A, right? And I'm using a dot length here. So the a dot length means it is a length of an array, right? So let me write it down here. A dot length is equal to n here. So n represent the total number of elements present in an array. So here hash represent the total number of elements present in an array. That is the meaning of n here, right? Now let's see. I'm taking the value of n is equal to 10. So is there any change in terms of an algorithm? So I'm going to execute all of these statements when the value of n is equal to 10. Similarly, if I'm going to take the value of n is equal to 100, or let's say the value of n is equal to 10k, 10,000. So is there any change in terms of execution of my algorithm? Right? So what did we observe? There is no change, right? The size of that array doesn't matter. The algorithm works perfectly fine, correctly, no matter what the size of n is. While executing that insertion sort algorithm, right? Here we are going to create some extra variable. What are the extra variable we are creating? So if you look at the function, the array A is an input. So the memory required for A to store the elements of A is already allocated. So we are not going to create the new array of A here, right? So this array is already given to me. So other than this, what additional variables are we creating here? What additional variable? So we created a variable called J. We created a variable called I. And we created a variable called key. So these are the three extra variables that I have created. Right? So let's say the values of j, I, key are the integers. Maybe sometimes the array contains the floating point numbers as well. But the number of extra variables are remain same. Right? So what did we observe from this context? That regardless of whether the array has 10 elements or 100 elements or 10,000 elements, we are still using only these three extra variables to execute the pseudocode or an algorithm. So no matter how large the input array is, the insertion sort uses a constant amount of memory, extra memory. So in this case, the constant extra memory is a 3 variables, right? And the constant number of variables, so we use a constant number of variables, and this is a very important because variables occupies the memory, right? Whenever you execute the code, and these variables will get created in the main memory or a RAM, right, to store all of these values, right? So we need a memory or a RAM. So regardless of whether the input array has 10 elements or 1000 elements or 10,000 elements, we are using the constant extra space or the constant amount of extra memory, that is 3 variables, right? So here I'm using the word constant, right? Very deliberately here, because these three variables are independent of the size of my array, size of the input array. So I'm not using any additional memory apart from what is already given as an input, right? If you look closely at how the algorithm works, you will notice that you are simply moving an elements around within the array. Let's say this is my array, right? So let's say array contains some number of elements. So as part of this algorithm, we are moving the element, right? We are not going to create the new one. If you look at that algorithm closely, right, you can simply notice that moving that elements around within that array. So we are not creating the new array. We are just shifting the values or copying the values and placing them back, all within the original array itself. This is exactly what in place mean. The place in place literally means within itself. So we are modifying the array in the same memory location that was originally allocated to it, right? And here you should not consider A as an extra amount of memory, right? So A is already given to us as an input to the insertion sort function. So we do not count its a memory as an extra. So the only additional memory we use it for is for three variables. Those three variables are I, j and key. That's it. No matter how the large array A is, the extra memory used by insertion sort remains the same. So it doesn't grow. This number doesn't grow with the size of an input. Now let me give you an example of contrast this with an algorithm where if you are given the array of size 100, let's say this is my array of size 100, and you create another array, let's say B, of the same size, let's say 100, for sorting an array. So for sorting the given input array, I just created a new array of size 100. So in that case, the algorithm would not be in place because I created an additional memory used depends on the input size. If the input size is 100, I created the another array of same size. Let's say my input array is 1000, array size is 1000. I'm going to create the same array of same 1000 here. So in case of an insertion sort, doesn't do that. So it only uses the fixed or the constant amount of extra memory and rearranges the elements within the original array itself. That is why insertion sort is an in-place sorting algorithm. And you will appreciate this concept even more when we study the other algorithms that are not in place, and we will get to those later, little later. For now, just remember, in place means an algorithm perform its operation without creating an extra space proportional to my input size. So the extra space doesn't dependent on the input size. That is the meaning of an in place. Now we will take this slowly, one concept at a time, and everything will become clearer as we progress through the course.